Get started because I am concerned that timing might be tricky here. So, welcome everyone. This first slide is sort of an illustration of what we're going to talk about today. So you can see we've got some sort of object here that is starting very fuzzy and undefined and is getting more defined and a clearer view on the right hand side. You'll notice this one has some artifacts in the picture. I haven't been doing this all that long, and disclaimer up front, I've been doing this for about a year. I'm not the Hubble telescope. I'm not the James Webb. You're gonna see some things that for sure aren't the coolest products they could be. But everything in this presentation is my own captures. Nearly all of them from my own driveway. There's I think one or two things that technically came from a different location, but I'll talk about those as well. This is sort of the agenda of what I hope to talk about. These 5 different steps, and sort of lead you through, again, what I've discovered in the past year of doing this, tips and tricks. All those things I'm going to try to encapsulate as much as I can along the way. We'll certainly talk about equipment that makes life a lot easier. But also throughout the way, I want to emphasize that you can do this on a budget for sure. This doesn't need to be crazy equipment in order to do this. So all these captures here are captures that came from my backyard. The one in the middle on the right, technically I took in Maine, where the skies were darker. But the rest of them came from my skies in my backyard. So intros, disclaimers. I think I hit most of the disclaimers already. And so what I'm actually talking about tonight, I mean, not tonight, today. I'm not necessarily talking about stars. I'm not going to talk about the moon. Not going to talk about planets. Things that are, in sort of the near sky within our solar system. Not going to talk about in this talk. Certainly interesting, certainly have their own challenges. But what I find most fascinating, and what hopefully I'll instill some fascination in everyone else, is the deep sky objects. So things that are in our galaxy. On the left-hand side there, you can see in the middle there, this like fuzzy rainbow donut. That's in our galaxy, the Milky Way. That's, a star that has collapsed and has thrown its atmosphere out into the space around it. The total size of that object is, if you can imagine our solar system was a grain of rice, compared to the size of a small car. That's how big that rainbow object is in space. You can see in the very middle, there's a real faint dot. That's what's left of the star that was throwing off its gas. So crazy things to think about and to contemplate. So the first thing when you're starting this, and I think the biggest challenge in a lot of ways, is, what the heck do I look at? Tim, what are you talking about? What is this donut on the side? What's these other weird objects here? What are we talking about here? And there's a few ways to get started there that don't require you to have a planetarium knowledge of the sky. I certainly don't today. The more you get into it, the more knowledge you get, like anything. But I certainly still rely on a lot of these tricks to find cool things to look at. One of the easiest ones is skytonight.com. You go there, I think it automatically finds your location. I don't think you have to actually do anything. I think you just go there and look. And it presents you a giant list of deep sky objects, and it's in order of magnitude. And what that means is how bright those objects are and how easily you'll be able to see them. So you go to that list, and probably right now it's got the Pleiades top of the list. That's the brightest darn thing you can look at. And the easiest thing that you're going to have a chance of seeing in binoculars or a telescope or a DSLR. I guess another quick disclaimer here is not necessarily going to talk about binoculars and telescope stuff. Mostly talking about taking pictures of deep sky objects. But a lot of the same principles are going to apply there for sure. So Sky Tonight, great place to start and to get a few ideas of, hey, these, someone told me that these are things I should look for. What do I do next? Another great place to start, and what you're gonna see referenced everywhere, is you're gonna see this M and a number, like M71, M23, all these sorts of things. What they're talking about there is what's called the Messier catalog. And that is a catalog of about 120 deep sky objects that some guys back 200 years ago found in the sky and cataloged. And what that generally means is they're relatively big and bright and reasonable things that you might have a prayer of seeing yourself. So that's another good place to start if you're wondering, what can I even look at? What can I expect to see? Sort of thing. And the next thing you're going to need from there is a smartphone app. Everyone's got smartphones. There's a bunch of apps out there for Android and iOS that you can download and just point at the sky, and it's going to tell you what you're looking at. Get one of those. It's the magic of technology and the internet tools we have today that turns backyard astronomy into a whole new accessible situation. Those apps are great. Make sure they're oriented right, make sure that when you're looking at it, if you know something like the Big Dipper, make sure that you can kind of see what that looks like in the app and what that looks like in the sky, so you can have a sense of sort of how that perspective changes. Find the bright objects so you can orient. Last night I was trying in vain to find this comet lemon that's supposed to be up right now. Could not find it. But there were two very bright stars that I was using to orient and to triangulate to try to find things. The other thing you're going to need is a clear, dark sky. No clouds. The moon is actually going to work against you for a lot of these objects because the moon produces a lot of light. So ideally, you want to go out in times like this week where the full moon is on the wrong side of the earth. So it's very, very dark at night. And you're going to want to have, cold temps, not a lot of air turbulence, not a lot of clouds, not a lot of weird moisture in the air. So there's another website, cleardarksky.com. You can go in and plug in your location, and it's going to have this chart graph at the top of the site that sort of says, how your viewing conditions are for these various elements. The most important thing is that there's no clouds, and the least amount of moon, the better. The other major thing that we're all going to be fighting is light pollution. So you do want to have a sense of the light pollution of your area. And that's all the street lights, the stadium down the road, the town next door, all this stuff is going to shine up into the sky and cause reflections off of the atmosphere that is going to make it harder for you to see stuff that's not even in our galaxy. So there's another website, darkskymap.com, that you can go to and look at your location and have a sense of, is it really bright on this side of town? And I might go over to the other side of town if I want to try to see something. Or, hey, I know that my cousin lives over in this dark spot, that looks a little better than my area. I'm going to go to his house and check things out from there. another thing to be aware of there is just sort of setting all that context. So you want to find a bright object. You want to know sort of how you can find that in the sky. Use the smartphone app. And then you want to go out on a night that's going to be conducive to finding these things. If you don't know what you're looking for and you're just going out on a dark night that's cloudy and there's clouds rolling through and you're next to Boston, chances are you're going to be disappointed. It's going to be very tricky to work with that. So you do want to do some homework ahead of time there to sort of understand what are the bright objects, where are they in the sky, north, south, east, west, what direction are we looking at, sorts of things. Little tip, the sun sets in the west. And chances are, unless you're a crazy person, you're going out after sunset. So the darkest skies are going to be in the east, where the sun comes from in the morning. And your darkest skies are going to be right overhead, away from the earth, away from all the other stuff. So you're going to have the most contrast to the east and up for most of what you're trying to do and look at. Any questions on that? All right, so let's talk about what you're gonna need to look at these things. And just a quick note on this slide, the top object is a galaxy, and the bottom object is a galaxy as well, with a meteor that's coming through the frame there. And this is another galaxy here. It's one of the two closest to us, which makes it an ideal target to try to find. So equipment. A lot of people are gonna think that this is inaccessible because you need lots of fancy, expensive equipment. Not true. I'm gonna talk about some fancy equipment, but I want to emphasize that you can absolutely take pictures of things with cheap equipment. And hopefully we'll have time at the end. I'll show you a little more detail about some of that. But the essentials that you need for doing photography of deep sky stuff, a decent DSLR. This could be a mirrorless technically, micro four thirds, fine, full frame, fine, APC, fine. Something that's decent there. The newer, the better. Obviously, new cameras have a ton of anti-noise features that are really slick and impressive, but a decent camera. The next thing you're going to need is a fast lens. And if you're not a photographer, you don't know what that means. A fast lens is a lens that can take in the most light possible. So if you're out there buying a lens, you're going to notice it's got this F number, f-stops, and you want to buy a lens that has the smallest f-stop number you can possibly get. And the other thing that you want to consider there as well is we're taking pictures of very, very, very small things. So you can get a fast lens, and if it's a wide angle lens, that's cool. You can take some pictures of the Milky Way, which is our galaxy. But for deep sky objects, you really want a lens that is fast, but also has a focal length of over 100 millimeters, I would say, full frame equivalent. A decent length there is 130, 135. There's a lot of options there, and there's cheap options there as well. So you can see the picture on the right here is a picture of Orion. Everyone knows Orion. Very easy to find. You get the iconic 3 stars and the belt and the sword hanging down. This was taken with a $25 vintage Minolta lens I got off eBay. f2.8, which is kind of the minimum that you really want to aim for. 135 millimeter length. And I think this is pretty close to the full frame that came out of it. But you can see that there's a number of nebula that appear in this picture. One of the easiest things that you can look for is the sword tip of Orion down at the bottom has this huge bright nebula. Super easy to find in the sky, super bright, super great target. That's going to be coming a few weeks from now. So it's November, mid-November now. And by early December, mid-December, late December, Orion's going to be rising at a time where it's super easy to go out and look. Great target. You don't need crazy equipment to take a picture of Orion. You will need a decent tripod. It doesn't need to be crazy expensive. Again, I've got a tripod that's for traveling, got it for, 20, 30 bucks off Amazon. The thing is kind of crappy. The mount's not that great, but hey, it's tight enough to point it at something, set it, and as long as there's not a hurricane flying around, you get a decent picture. The other thing that I'm going to say is essential for success as a beginner is the internet and a compass and the ability to connect to your camera and look at pictures that you're taking of the sky, so that in the next step from here, you can understand what you're looking at and how to orient onto the object that you want to find in the sky. Something like Orion, you probably could do that freehand. Point, look at your monitor, and just look until you see the 3 stars. That one's easy to find. You don't need crazy technique and equipment to get that. But if you really want to take it to the next level, look at smaller objects that are fainter, that are deeper in the sky, that are trickier to line up. There's some stuff that really helps out and that I'm going to talk about here as well, because for me, there was a lot of unknowns and not a lot of good documentation out there on the internet, not a lot of good walkthroughs on how the heck you work these things. The biggest next level thing you can do is get a tracking mount. So you can see in the middle picture here, at the top of the tripod, there's this thing that has a glowing red dial on it. And what this does is allows you to set up and orient your shot, and the mount is going to rotate at the same speed that the Earth rotates. So if you don't know, the Earth is spherical. It does rotate.
Fake news. The Earth is flat.
I thought it was flat as well.
I think it's more of a cube.
So if you're trying to do sky photography at night, that's one of the hard things to combat is you need to take long exposures. And if you start pushing your exposure 4 seconds, 5 seconds, 6 seconds, and you look closely at it, you're going to see that the stars are starting to trail. That's because it's like taking a picture of a car driving down the road. That there is motion happening there. And what the tracking mount does is allows you to counteract that motion in real time, so you can take longer exposures. And what you can do with a longer exposure is set your sensitivity lower on the camera so that you're introducing less noise. And that's really the name of the game with all of this other next level equipment, is allowing you to take in the most amount of light with the least amount of noise. So we already talked about the fast lens. That's certainly going to help. Decent DSLR is going to help. Being able to get that longer exposure is sort of that next element in that equation for getting the most amount of light with the least amount of noise. Hopefully everyone understands that noise is a digital artifact of a digital camera. Shows up as little speckles on the sensor, or looks kind of grainy or fuzzy. That's noise, and that's what we're talking about there. The other thing that's going to really help out is the longest, fastest lens you can get. Now, that gets into the territory of budget for sure. You can get, decent, cheap, long lenses. And you can, if you have budget, you can get even longer things. So I happened to previously do a lot of wildlife photography. I had this long zoom lens for pointing at birds. And I always thought to myself, oh, this is kind of a waste, you know, because what else am I going to do with this lens besides look at birds? You can look at the sky. It's a fantastic use for some of these specialized lenses that you might otherwise have a limited use for. And then the other thing that's going to be super handy is what's called a intervalometer. Hopefully I'm saying that actually correctly. Some cameras will have the ability to take multiple exposures built in that you can just change in the menus and say, hey, you know, take 10 shots in a row. If you don't have that ability, you can usually get an external device that plugs into the camera that will let you say, you know, hey, I want 30 shots of 10-second exposure. Click a button, let it rip, type of thing. That's what an intervalometer is. The tracking mounts sometimes have this built in. Certain cameras also, you can do this in a smartphone app if you have that ability. So there's other ways to slice that cake. The tracking mounts are pricey. I got this one for a special anniversary present. Was not something that I would normally necessarily go out and budget for and buy. I think it was a couple $100 for the tracking mount.
Hey Tim, do you have the model number of that? And do you like it? Like, would you recommend it?
Yeah. This is the Star Adventurer 2i, I think. And it's fantastic. I absolutely love it. Rock solid, small enough to throw in a backpack. Super, super cool device if you're into this kind of thing. That's the basic equipment. Any questions on equipment? Any other questions?
Have you ever used, because I'm thinking about, my son has been asking for a telescope for Christmas. And every once in a while I see ones that, oh, telescope, it takes photos too. Like, I don't know, have you ever had experience with those at all? Or is that more like a gimmick type of thing, or?
You know, I've seen some things.
Smartphone, but no.
I've seen some things out there that, you know, Jim showed me one recently and some other folks. And to me, knowing that I have, you know, a giant lens and a fancy camera and a fancy mount, and I'm getting this level of image quality, to me, it makes it really hard to imagine that I could get a bigger or better image from something that's a lot less substantial. You know, like I don't think there's magic out there per se. Just to make note of it, smartphones these days with their night capture features are crazy. You can actually get some images of things with your damn phone just pointing at the sky. So yeah, I would treat those skeptically, all the way saying. Any other questions? I see there's something in chat, but I don't know how to get to chat. If you have questions, definitely just shout them out. And if I missed anything, I'll try to check the chats at the end. All right, so I'm going to talk about the equipment I have, because for me, there's a lot of things here that I had no clue and kind of stumbled across and had to figure out along the way. And I think that's some of the value I can hopefully impart in this is if you do go out and buy one of these tracking mounts and try to point it at the sky, this is what you're going to have to do. So the first thing you need is the mount needs to be balanced. So you'll notice back here, there's some weights that are kind of sticking towards the perspective here, and then the camera is actually behind those, and there's this green thing in the middle. So that whole thing is spinning very slowly. And what you want to do is have that balance so that nothing is trying to sway dramatically out of balance, because you've got this very fine motor that's trying to very carefully move that thing, and you want it to be as neutrally balanced as possible. A tip there is that the sprayers in your sink have that hose, and they sell a little weight that can go on that hose. It's the fantastically perfect size to add weight to your arm there on the mount. So if you've got some kind of ridiculous lens here, like I've got my birding lens on, you can see I got 2 weights technically on the end of that mount, and that's because I needed the extra weight to balance it. This particular tracking mount, I think, caps out around 7 or 8 pounds. You're not going to be able to mount a freaking telescope on the thing and expect it to do its thing. But you can put a decent amount of weight on it for sure. Next thing that you need to have is the mount needs to be level. You're lining up geometries with the entire Earth. So you really want to have that central geometry as close to pointing to the center of the Earth as possible. This mount happens to have a little bubble on it, which helps you do that. But just a note, you definitely want to do that. And you want to do that up front, not after you align the whole damn thing and then try to level it. You're gonna not like that. Next thing you do with this mount is you have to align it to Polaris. So if you don't know, everything's rotating, and everything in the sky from our perception is rotating around a star called Polaris, the North Star. It's in the Little Dipper. If you look north and you go about 40, 45 degrees up from the horizon, it's going to be up in that range. It's going to be one of the brightest stars in that range. So if nothing else, you want to get your compass, you want to point north, you want to look through your little viewfinder and try to find the brightest star that makes sense there. One thing I didn't note on here that you'll also need to do with this mount is adjust the angle for your latitude, I believe, how far north or south we are. You can just Google it, and say, hey, what's my degrees of latitude, and you'll plug it in there, and that's gonna more or less point you at the level where you expect to get Polaris.
So the compass app on iOS at least has longitude latitude coordinates built into it. Just noticed. So.
Perfect. Yeah. So good point. You can get a compass from most smartphones these days. I would say one thing I've noticed there is just to be careful about electronic interference. That will throw off the electronic compasses quicker than a physical compass. So if you're having trouble with that, always check something else, check another phone, check a physical compass, say, hey, does this make sense? The sun was there. Is this actually north? All those sorts of things. So the tracking mount has a little scope on it for aligning with Polaris, and on the right hand side here, that's what you see in the blue picture is a real life view down that scope. Excuse me. So it gives you this these crosshairs here for aligning Polaris, and what's nuanced here is you're not actually putting Polaris on the X of those crosshairs. What you're actually doing is putting Polaris off the X and onto the circular diagram here. So in order to do that, to get your highest level of accuracy there, it's best to use another app. I linked it here, Polar Aligner Pro. And what this does is tells you exactly on that circle where you want to put Polaris for a given day in the season. If you don't have that app, yeah, just crosshair it as tight as you can, and you're going to get a decent alignment. If you really want the tightest alignment possible, get some kind of app or web reference or something that's going to tell you, okay, you're putting this in, that northeastern quadrant of the circle, right in the middle there. And you can see here that that's kind of how these two are aligned here. Any questions on aligning to Polaris? Does that make sense? Next thing you do is that the mount actually has several different speeds of rotation. So for the stuff we're doing here, you want to turn it on to star tracking mode. And that's going to set it up for the rotation for deep sky objects. If you're trying to take a picture of the moon or the planets, those are rotating at different speeds technically than the deep sky is relative to your position. So for this instance, we want to turn on star tracking mode. And you can go ahead and turn that on as soon as you're in alignment there. And the next thing you do is that hopefully you have something in mind up in the sky. You have a sense of where that is. You want to use your knowledge of the constellations, use your knowledge of the app to roughly line up the camera. And the easiest way to do that is to just look down the lens like it was looking down a rifle that you're trying to shoot. And to point it to as closest as you can approximate to that location. If you're using a zoom lens, you want to start with the lens zoomed all the way out while you're tracking your object. And only when you find your object in the sky and you center it, then zoom in, then redo everything again. Roughly line it up. On the camera itself, jack up the ISO, jack it way high. It doesn't matter at this point. We're just trying to find the object. So you want to bring that up high so that you can manually focus onto the stars. So we're not using any autofocus here. This is all manual focus, which budget-wise is great because then you can use old lenses that don't have autofocusing because it doesn't matter. We're manually focusing everything. Disable image stabilization. This is another one that bit me for a long time and I didn't understand what was happening. It's the image stabilization can cause weird artifacts and errors in the rotation. Turn it off. It doesn't know how to play well with what's happening. Camera focusing. So you want to do some rough focusing at this point. Generally speaking, the lens is going to have an infinity point. And you can start by turning your lens all the way to infinity, making sure that your f-stop is set to the lowest number. And then look at your live view at the stars and adjust your focus until the stars are the smallest possible. So you're going to start with this big out of focus blob and you're trying to reduce that blob into the tightest point of light possible. The other trick to focusing is to look for faint stars that aren't there until you're in focus. And then boom, all of a sudden you'll see there's a bunch of faint stars that you didn't see before. So you want to look for that as well. There's other tricks you can do, like focusing ahead of time on a distant object and then taping your focus ring. I don't particularly like that because you're going to need to be refocusing throughout your conditions. So you can't necessarily count on that to be the magic trick. Another sort of obvious thing, but it's easy to forget, your mount, if you have an auto mount, is rotating. If you've got cables, they're going to be rotating. You got to, get ready for those cables to move around. If you're putting it next to your house because that's where the power socket is, it's got to have space so that you're not slamming your giant camera into the side of the house. I know from experience on most of these. Does that make sense for how to set up that autoscope? All right, we're going to talk
question about just after the fact, the Polaris thing. where you align Polaris with the inside the circle, does it matter which point inside the circle that you line up?
Yeah, so it's gonna be in the orientation that you see in your reference. So on the black screen here, that's the app. And the app is saying to put it in that upper middle
Oh, I see. Okay,
quadrant.
so it's telling you to put it in that area. I gotcha.
So then you can see in the blue one that one's kind of aligned in that same upper middle quadrant on the circle.
Great, thanks.
Yeah. So hunting. This can be the most frustrating, but also the most rewarding part of this whole thing, is just finding the darn object and seeing that first image come in is incredibly rewarding. Be prepared, it can take a long time. It could take you an hour to find the object, sort of time frames. Some things much easier than other things. So what I'm going to talk about here is a lot of using this website called astrometry.net. This is an amazing site that is going to save you an incredible amount of headache. So you wanna kind of know what you're looking at where in the sky. So you found your thing previously. Your cell phone app may or may not point out things like galaxies and nebula. If it does, cool. If it doesn't, just go to Google and say, hey, I'm trying to find the location of Messier 101 and do an image search. And what you're going to see is a lot of results sort of in the middle of the screen here, this black and white image, where you can see the tail end of a constellation. This is the Big Dipper tail end coming in. And it shows you where the object is and even the relative size of what that object is compared to the constellation. That's going to give you basics. Where the heck am I looking in the sky? In order to get locked onto your target, what I use is this website, astrometry.net/upload. And what this does is allow you to plate solve an image. And what that means is that it's taking your image and comparing the locations of the stars in your image against a giant database, and then showing you, hey, 99% chance this is exactly what you're looking at. So you can see on the right-hand side here, this is the results of an image upload. The image in the middle is one that I took trying to locate M74, which is a very, very dim galaxy. I added the finger for emphasis. It does not add that. So you can see on the bottom right-hand side, it's showing you a little white square, and that's your frame of what you took a picture of. And it's showing you where that frame lands on the constellation. And then on the actual image where it's all in green, you can see that constellation overlay, that big line that's coming through. That's Pisces. So you can reference against that and say, okay, I'm lining up against Pisces. And in a lot of times, you don't even see the object necessarily in the picture you're taking. In that one quick image, you can see in this one of M74, that galaxy is very faint. You can't even see it in the picture. Most of the time, you will see something. If we go all the way back to the beginning here, this left-hand most picture, that's a single exposure. There's something there. It certainly doesn't look like the sunflower galaxy on the right here, but most of the time you see something. Sometimes you see nothing. And that's where the technology really comes into handy, is that you can know that, hey, I'm taking a picture of something. Even if I can't see it currently, I might have a chance of pulling it out in post-processing. Time is going quick, so I'm gonna try to rifle through these a little quicker here. So you take that picture and you're not going to be lined up perfectly on your object. Chances are you're going to be significantly off of where you want to be. You use the data from astrometry.net, looking at that constellation, to change your orientation to find your object. So you want to do this methodically. chances are your lens is coming out with a rectangular picture. So you know that you'll have an up and down axis and a left and right axis. Move methodically. Watch the stars in your viewfinder and watch the patterns of how they're moving in your viewfinder. And that's going to help you move through the map on astrometry.net. So you take a picture, you're way off. Hopefully you're not that far off that you can understand, okay, I need to move to the left and up. And then I'm going to methodically move my orientation carefully in those directions. So eventually you find your object, and that's the rewarding part. As you can see here down on the right-hand side, this is a single shot of Sunflower Galaxy, the first galaxy that I had up here at the very beginning. This is that galaxy. This is that single shot. So you can see it's faint, but at least in that single shot, you can see something is there that looks like a galaxy. Center it in, zoom in, refocus. After you zoom, refocus. Now is when you're setting your exposure time to get the most amount of signal to the least amount of noise, the most amount of light. So generally speaking, you always want to shoot in RAW at this point. And you want to adjust your exposure time and your ISO to the point where you're not getting a white blown out picture, but you're also not getting a super dark, high contrast black picture that you can't see anything. The way to do that is to use the histogram. And when you take these pictures, either on the camera or on the laptop you're connected to the camera, or on your smartphone that's connected to your camera, something that you can get a histogram view. And that's going to tell you roughly where the data is in the spectrum of possibility there. And you want to have your histogram peak to be about 1/3 to 1/4 off of the left-hand side of the spectrum there. If it's way over to the right, chances are you're overexposing. You want to reduce your ISO, reduce your exposure time. If it's way over to the left, you're underexposing. You want to introduce your exposure time, but without trailing any stars. And you want to up your ISO at that point. All right, so we're running quick on time, so I'm just going to plow through these next steps. The next thing that you do to get pictures of these deep sky objects is called stacking. So you take a single shot, doesn't look that impressive. You know, you can kind of see, there's maybe a galaxy in the middle there. Hard to really know. When you get the impressive pictures is you take hundreds of pictures of the same thing, and then you stack them in post-processing. What that does is allows the software to filter out the noise from the actual signal. So if you've got, 100 different samples of the same thing, the software can tell that, hey, this is all just noise off the sensor, and these other pixels, these are the ones that are actually the object. So stacking. There's a program, Deep Sky Stacker, freeware, good, legitimate program out there. You're going to see stuff about darks, flats, and biases. Ignore it for now. Don't worry about that. What you really want to worry about is taking higher numbers of low ISO pictures. So I generally aim to take, at least an hour worth of exposure. So if you're taking, 10-second pictures, you calculate that out to how many pictures you need to take to get an hour to get a decent shot. You can do this with a lot less as well. If you only got 10 minutes, take 10 minutes of pictures, whatever, it doesn't matter. You're going to want to drag in all those pictures you took in raw format. There's an option here that says check all. That's what you want to hit, check all. That's going to select all the pictures. Just use the defaults off the bat. There's all sorts of stacking algorithms in there. that you can play with, but off the bat, the defaults are just fine. So you hit check all, and then you hit register pictures, and that's going to start the stacking process. And this can take a while, depending on the computer and what you're doing. This can definitely take some time. Eventually, you're going to get output that looks like the output here. It again doesn't look that impressive, looks kind of dark, but what it is very high fidelity. There's not a lot of noise. Which comes into play, and the final process of this is post-processing. So you're taking that high fidelity image, that's huge, it could be like a 10 gig image, and you're dumping this into Photoshop or Gimp or some tool that you're familiar with in order to do dynamic range processing essentially on it. This is the lost my advance here. 1 second. All right. This is the bit that can also be very frustrating and time consuming, and it has a lot of unstructured approach. There's certain things that you have to do when you get these files out of Deep Sky Stacker. First thing you're going to want to do is convert it down to 16-bit so you can actually get a histogram to work with. In Photoshop, that's going to prompt you for this HDR toning by default. You want to set that to exposure and gamma on neutral. Don't worry about playing much with that at this stage. From there, what you're essentially trying to do is bring out the shadows brighter and the highlights darker. So there's a couple of key tools that you do with that. One is the curve tool. You can do very fine mid to high boosts just by dragging that curve up a little bit. But the bulk of what you're going to be doing is using the levels tool in order to bring out those faint objects so that you can actually see them. In the levels tool, what you want to do is take the low slider on the left-hand side and drag that right up to the bottom of the histogram. And then on the right-hand side, you want to play with the mids and highs and dragging those down closer to the histogram. And this is all a tug of war between the object that you're trying to pull out and the background light pollution noise and the stars. So essentially, you're just squeezing and squeezing and squeezing that data to bring out as much of the low signal as possible and as little of the high signal as possible. There's also some fancy selects and fancy fills that you can do to help with this, but that's the meat and potatoes. Along the way, you want to be keeping your RGB sort of in line. It's very easy to forget about that and to start getting skewed color wise, and you wind up with some really weird, righteous looking color palettes. It's easier to do each of those channels independently. And rinse and repeat, rinse and repeat. Slowly, you'll see that your picture that's very dark and very dim finally starts to show an object after doing this many times over. I'll do some final touch up in Snapseed. You could do that in any app that you're familiar with. Local noise reduction, enhancing structure and brightness and color, doing magic tool tweaks. This gets into a little bit of artistic interpretation at some point, but you can see some examples here. The bottom one is that Phantom Galaxy from before. So here, M74, we're on the single frame, you can't see anything, nothing even there. After processing and stretching and stacking up for 2+ hours of data, what you get is this picture on the bottom here. Out of Photoshop, it looks a lot like on the right. Still pretty noisy, but you can tell definitely that there is something there. You can clean that up a little bit so it looks more like a presentable galaxy. On the top right-hand side, this is Andromeda M31. It's up right now, definitely a great target. And these 3 different pictures kind of go from a single exposure on top that you can see that there's something there. Looks pretty weird, but something is there. To a more cleaned up picture on the left, and then a final product on the right. These aren't even that great, but you can definitely see that you're going from taking very minimal amounts of data to taking turning it into a reasonable picture. Here's a couple other examples of sort of what to expect here. On the left-hand side, this is that ring nebula from earlier. And you can see this is a full frame picture at 600 millimeter zoom on a full frame camera. So the object that we're looking at is actually very, very, very tiny in this instance. And then you crop in on that and you can see, you know, obviously a lot more detail, but just to set the perspective on some of these is they're very, very small. On the right hand side is a very similar nebula. This is the dumbbell nebula. And the left hand is just a single exposure off the camera. You know, you can see that something is there, but it's not nearly as high contrast and clear as when you stack it and post process it and get to the final right hand side picture. And then these are examples of stuff I've done in the past year. Lots of galaxies. Galaxies are great objects because they're full spectrum. They're going to punch through light pollution a lot easier than nebula. Nebula are often ionized gas emissions. So it's like a fluorescent light, you know, has a gas in there that's ionized. It comes out very thin spectrum. It can be a little harder to capture. That's it. I do want to leave a few minutes for questions.